Have you ever wondered about the geometries that do not satisfy the postulates of Euclidean geometry? Yes, such geometries do exist, and they are known as non-Euclidean geometries. Euclidean geometry, as you may recall, is based on 5 postulates, one of which is the parallel postulate. This postulate states that for any given line and a point not on that line, there is exactly one line through that point that runs parallel to the given line. However, in non-Euclidean geometries, this parallel postulate does not hold true. There are 2 primary types of non-Euclidean geometries: hyperbolic geometry and elliptic geometry. Dive into the world of hyperbolic geometry, where the parallel postulate is replaced with a different assumption. For any given line and a point not on that line, there are an infinite number of lines through that point that run parallel to the initial line. Yes, you heard that right, an infinite number of parallel lines. On the other hand, elliptic geometry takes a different approach. In this geometry, for any given line and any point not on that line, there are no lines through that point that are parallel to the given line. It might seem counterintuitive, but that's the beauty of elliptic geometry. Non-Euclidean geometries have found numerous applications in various fields. Hyperbolic geometry, for instance, is utilized in modeling the geometry of spacetime in Einstein's theory of general relativity. On the other hand, elliptic geometry is used to model the geometry of the universe on a macroscopic scale. For real-world examples of non-Euclidean geometry, look no further than the surface of a sphere, an example of elliptic geometry. Here, there are no parallel lines as all lines eventually intersect. Similarly, the surface of a saddle, an example of hyperbolic geometry, has infinitely many lines through any point that are parallel to any given line. In conclusion, non-Euclidean geometry is a captivating and significant area of mathematics, with applications spanning across physics, mathematics, and computer science. It challenges our conventional understanding of geometry and opens up a whole new world of possibilities. Whether it's the infinite parallel lines of hyperbolic geometry or the absence of parallel lines in elliptic geometry, non-Euclidean geometry truly is a fascinating realm of study.